Assalamu alaikum warahmatullahi wabarakatuh. Welcome back to our sixth and final episode of this journey, the performance test. The performance test of semi-solid drug products in the United States Pharmacopoeia will provide general information for in vitro testing of semi-solid drug products. Semi-solid dosage forms include creams, ointments, gels, and lotions. Drug product tests. Drug product tests are divided into two categories: those that assess general quality attributes and those that assess product performance. Example, in vitro release of the drug substance from the drug product. Drug product quality tests are mentioned before. Taking these drug product tests together is to ensure the identity, strength, quality, purity, compatibility, and performance of semi-solid dosage forms. Products performance tests for semi-solid drug products are conducted to assess drug release from manufactured pharmaceutical dosage form or assess attributes that relate to in vitro drug performance. The release rate of a given product from different manufacturers is likely to be different. Note that the in vitro performance tests for semi-solid products do not directly predict the in vivo performance of drugs, as the primary factor that impact bioavailability and clinical performance are the barriers of the epithelial to which the product is applied, meaning that the drug performance tests do not directly measure bioavailability and relative bioavailability. They can detect in vitro changes that may correspond to alteration in vivo performance of the dosage form. These changes may arise from changes in physicochemical characteristics of the drug substance and or excipients, or the formulation itself. Changes in the manufacture process, shipping and storage affect aging effects and other formulation and or process factors. There are several available apparatus that can be used for product performance testing, and they include the vertical diffusion cell, immersion cell, and special cell used with US Pharmacopoeia apparatus 4. The primary use of in vitro drug release testing is comparison testing, in which any difference in delivery rate is undesirable. In vitro drug release testing is most suitable for evaluation of small formulations and process changes, manufacturing site changes, and stability testing. The evaluation or comparison of large formulation changes may provide unmeaningful results, unless extensive validation is performed to select test parameters that ensure that the sensitivity of the test is meaningfully correlated with in vivo performance. The only required regulatory use of the in vitro release test is to determine the acceptability of minor process and or formulation changes in approved semi-solid dosage form. In vitro performance test, diffusion cell. Diffusion cell testing is a reliable and reproducible way of measuring drug release from semi-solid dosage forms. It is a cell that consists of two primary chambers separated by a membrane. The test product is applied to the membrane via the top chamber, the donor chamber. The bottom chamber, the receptor chamber, contains fluid from which samples are taken at regular intervals for analysis. This testing determines the amount of active drug that has permeated the membrane at each time point. The momentary rate of drug release becomes proportional to time, which reflects the slowing of drug release with the passage of time. The reservoir is kept large so that over the entire course of the experiment, the concentration of the drug released into a medium remains highly dilute relative to the concentration of drug dissolved in the semi-solid. In these circumstances, drug release is said to take place into a diffusional sink. When the drug release is in the form of a suspension in the dosage form, the amount of drug released as a function of time can be described by this equation. M equals the square root 2 times dm times cs brackets q minus cs divided by 2 close brackets times t, where m equals the amount of drug released in the sink cubic meter, dm equals the drug diffusion coefficient in the semi-solid matrix, cs equals drug solubility in the releasing matrix, and Q equals total amount of the drug in solution and suspended in the matrix, and T equals time. When Q is larger than CS, the equation simplifies to M equals square root 2 times Q times dm times CS times T. A plot of M versus time will be linear with a slope of M equals square root 2 times Q times dm times CS. Drug release rate determination using vertical diffusion cell apparatus. The vertical diffusion cell, or Franz cell in a simple, reproducible test for measuring the drug release from creams, ointments, and gels. It is rapidly emerging as the apparatus of choice for the in vitro testing of drug release of topical semi-solid dosage forms. The cell comprises two parts: the sample holder, containing either 250 mg or 425 mg of the sample to be tested, and the reservoir of the diffusion cell itself containing the receptor medium. The two parts are separated by a membrane designed to act as a conduit for diffusion to take place and which serves to contain the test sample whilst ensuring that it remains in contact with the receptor medium. The receptor temperature is usually set to 32 degrees Celsius to approximate normal skin conditions. For each cell, the amount of drug release at each sampling time is determined, and the cumulative amount released plotted versus the slope of the resulting line is a measure of the rate of drug release. Normally, no fewer than 6 samples are taken over a 6-hour period, say 0, 5, 1, 2, 4, 5, and 6 hours, and analyzed using the HPLC or similar analytical technique. See Figure 7 Model A, Figure 2 Model B, and Figure 3 Model C. Leaving you with a short video to explain this apparatus. Drug release rate determination using immersion cell apparatus. The immersion cell is an alternative method of the vertical diffusion cell. The cell is designed to accommodate a 25 mm diameter membrane. It comprises 4 main parts. 1. A retaining ring which secures the membrane to the cell body. 2. A washer which holds the membrane in contact with the symbol. 3. The membrane or skin. 4. The cell body which contains the compartment in which the sample to be tested is placed. The cell is also provided with an alignment tool that allows the user to vary the volume of the reservoir within the cell. The results are treated the same way as vertical diffusion cell apparatus. Leaving you with a short video to explain this apparatus in details. Drug release rate determination using US Pharmacopoeia apparatus form. Flow through cell. The adapter for semi-solid dosage form in figure 8 is used with the 25.6mm cell of US Pharmacopoeia apparatus form. The USP apparatus for consists of the following: a reservoir, a pump for the distillation medium, a flow-through cell, a water bath. The pump has a delivery range between 240 and 960 ml per hour, with standard flow rates of 4, 8, and 16 ml per minute. It must deliver a constant flow. The flow profile is sinusoidal with a pulsation of 120 plus minus 10 pulses per minute. And now, here we are at the final destination of our journey. Hoping you had a fun time learning with us about the quality control of ointments and creams. Until we see you again in another journey.